What if everything you thought you knew about the universe was wrong? What if the stars above that have beckoned humankind since our earliest ancestors looked up in both wonder and fear, held deeper, more profound mysteries? Mysteries that challenged our very understanding of reality itself. From parallel dimensions to the mind-bending idea that we're living in a simulation, the universe holds secrets that defy our wildest imagination. In this video, we're diving into the craziest, most baffling theories about the cosmos that will leave you questioning everything you thought was real. We'll explore the edges of human understanding, peering into the quantum foam from which our universe sprang forth, and grapple with concepts that make even the most complex equations in astrophysics look like child's play. Hold on tight, because we're about to embark on a journey that will take us to the farthest reaches of space and time, and the destination just might be more incredible than any science fiction writer could have conjured. Stick around until the end, because the final theory might just make you rethink your entire existence. Have you ever played a video game so realistic that for a moment, you forgot you weren't actually inside the game itself? Now imagine a civilization millions of years ahead of us, a civilization with computing power so advanced, it could simulate an entire universe down to the smallest detail. That's the premise behind the simulation hypothesis. This theory suggests that we're not living in a real physical universe, but in a sophisticated, meticulously crafted simulation, indistinguishable from reality. Think about it. Every atom, every star, even the fabric of space-time itself might simply be lines of code in a cosmic computer program. The idea isn't as far-fetched as it sounds. Elon Musk, a man known for pushing the boundaries of technology, has stated that there's a high probability we're living in a simulation. He's not alone. Many physicists and philosophers have also entertained this mind-boggling possibility. But here's the real kicker: if we are in a simulation, who are our simulators? Benevolent creators observing our progress? Or perhaps we're nothing more than digital lab rats in some grand cosmic experiment? And if that's the case, what is the purpose of our existence within this simulated reality? The implications are staggering. If our actions are predetermined by lines of code, do we even have free will? Or are our choices merely an illusion, carefully orchestrated by our digital overlords? And perhaps the most unsettling question of all, is there a way to break free from the simulation? Some theorists believe that glitches in the fabric of our reality, those moments where the laws of physics seem to break down, could be evidence of our simulated nature. Imagine for a moment finding a crack in the code, a window into the true reality beyond our digital confines. Would we dare to reach through? The simulation hypothesis challenges everything we thought we knew about the universe and our place within it. It's a chilling thought, but one that forces us to confront the fundamental question: what is real and what is merely a figment of a highly advanced computer program? Let's dive even deeper into the rabbit hole of reality-bending theories. Imagine our three-dimensional world, with all its depth and complexity, as nothing more than a projection. A projection, not onto a screen, but onto the very fabric of space-time itself. This is the essence of the holographic universe theory. Picture this: just as a security chip on your credit card can store a vast amount of information in a two-dimensional form, the information that makes up our three-dimensional universe, including time, could be encoded on a distant two-dimensional surface. This isn't just philosophical pondering, mind you. Scientists studying black holes, those enigmatic cosmic monsters, have discovered that the information about a black hole's content seems to be proportional to its surface area, not its volume. This finding lends credence to the idea that information in our universe might be holographic in nature. But what does it actually mean to live in a hologram? Does it mean our reality is less real? Not necessarily. Think of it this way: the information that makes up your favorite movie is stored on a flat DVD, yet when you watch it, the characters and stories come to life in a three-dimensional world on your screen. Similarly, the information that makes up our universe might be encoded on a distant surface, projected into the three-dimensional reality we experience. The difference is, we are inside the projection, not observing it from afar. The holographic universe theory has profound implications for our understanding of space, time, and even consciousness. If our reality is a projection, what is projecting it? And what happens to our consciousness if the projection ends? This theory suggests a deep connection between the universe's fundamental structure and the information it contains. It challenges us to rethink our place in the cosmos, not merely as observers, but potentially as projections of information encoded on a cosmic canvas far beyond our reach. The holographic universe may sound like something out of a science fiction novel, but the more we learn about the universe, the more we realize that reality itself is far stranger, far more mysterious than we ever imagined. Let's say you're faced with a life-altering decision. Do you take the job offer or start your own business? Now, imagine that for every decision you make, a new universe is created where the opposite choice unfolds. Welcome to the mind-bending concept of the multiverse. The multiverse theory proposes that our universe is just one of an infinite number of universes, each with its own unique set of physical laws, constants, and even alternate versions of ourselves living out every possible permutation of our lives. Think about it. In another universe, you might be a rock star, a world-renowned chef, or even the president. The possibilities are as limitless as the multiverse itself. This isn't just a flight of fancy. Quantum physics, the study of the very small, provides tantalizing hints that the multiverse might be more than just a theoretical possibility. The many worlds interpretation, a theory in quantum mechanics, suggests that every quantum measurement, every interaction at the subatomic level, causes the universe to split into multiple universes, each representing a different outcome. If true, it means that countless versions of you are out there right now, living out different lives in different realities. Some universes might be remarkably similar to ours, while others could be unimaginably different, with different laws of physics and even different dimensions. The multiverse theory isn't without its critics. Some argue that it's impossible to prove or disprove, while others question its scientific validity. However, the idea continues to capture the imaginations of scientists and laypeople alike, offering a tantalizing glimpse into the vastness and strangeness of the cosmos. Imagine the possibility of one day developing technology that could allow us to peek into these alternate realities, or even travel between them. What would we find? Would we meet other versions of ourselves? The implications are as mind-boggling as the theory itself. The multiverse theory challenges us to expand our definition of reality and consider the possibility that our universe is just one of an infinite number of bubbles in a cosmic sea of possibilities. It's a heady concept, but one that opens up a universe of possibilities literally. We know the universe is expanding, a fact confirmed by Edwin Hubble's groundbreaking observations nearly a century ago. But what if this expansion, the very fabric of space-time stretching outward, never stops? What if it continues to accelerate, faster and faster until it reaches a point of no return? This is the unsettling premise of the Big Rip theory. Imagine a universe where the expansion becomes so relentless, so powerful, that it overwhelms the very forces holding matter together. Galaxies would be torn asunder, stars ripped apart, and even the very atoms that make up our bodies would disintegrate into their constituent particles. It's a scenario that evokes a sense of cosmic horror, a universe unraveling at the seams. The driving force behind this cosmic unraveling is dark energy, a mysterious force that makes up roughly 68% of the universe's total energy density. We know very little about dark energy, but we do know that it acts as a kind of anti-gravity, pushing everything in the universe apart at an accelerating rate. If the Big Rip theory holds true, then the universe's end won't be a grand collapse, a cosmic crunch where everything is pulled back together. Instead, it will be a violent, relentless tearing apart, a cosmic dissolution that obliterates all structure and order. The scariest part? Scientists don't know exactly when or if the Big Rip will occur. It could be billions of years from now, or it could be much, much sooner. The fate of the universe as we know it hangs in the balance, subject to the whims of a force we barely understand. But there's a glimmer of hope, a possibility that the Big Rip might not be the inevitable end. Some theories suggest that dark energy might not be constant, but could change over time, potentially weakening or even reversing its effects. The Big Rip theory serves as a stark reminder of the universe's immense power and our own fleeting existence within it. It forces us to confront the possibility that everything we know, everything we cherish, could one day be torn apart by forces beyond our comprehension. But it also inspires us to delve deeper into the mysteries of the cosmos, to seek answers to the universe's most profound questions, even as the clock ticks down on our cosmic existence. For millennia, humans have gazed up at the stars and wondered, are we alone? The universe is vast, teeming with billions upon billions of stars and likely even more planets. Statistically speaking, it seems almost impossible that we are the only intelligent life in the cosmos. Yet despite decades of searching, we found no definitive evidence of extraterrestrial civilizations, no radio signals, no megastructures, no signs of alien life whatsoever. This eerie silence, this cosmic loneliness, has led some to propose a chilling possibility: the Great Filter. The Great Filter theory suggests that there's a barrier, a filter of sorts, that prevents intelligent life from reaching a certain level of technological advancement or spreading throughout the galaxy. This filter could take many forms, from self-annihilation through nuclear war or environmental destruction to natural disasters on a cosmic scale, like gamma-ray bursts or asteroid impacts. The theory posits that every civilization in the universe faces this filter at some point in its development. The question is, where are we on this cosmic obstacle course? Have we already passed the Great Filter, suggesting that we're one of the lucky few civilizations to have made it this far? Or does the filter lie ahead, a looming threat to our future existence? If we have already passed the filter, it might explain why we haven't encountered any other advanced civilizations. They simply didn't make it. But if the filter is still ahead, it could mean that humanity is on a collision course with its own demise. The Great Filter theory is a sobering reminder of the fragility of life, especially intelligent life. It challenges our anthropocentric view of the universe, suggesting that we are not special, not immune to the forces that might have already wiped out countless other civilizations, but it also serves as a call to action. By understanding the potential threats to our existence, we can better prepare for them and perhaps even find ways to circumvent them. The future of humanity might depend on our ability to identify and overcome the Great Filter. Perhaps the greatest lesson of the Great Filter is this: the universe is not obligated to be kind to us, nor is it obligated to preserve our existence. The survival of our species, the future of intelligent life in the universe, depends on the choices we make today. As we've explored these mind-blowing theories, one thing becomes abundantly clear: the universe is far stranger, far more mysterious than we ever imagined. These theories are more than just fascinating ideas. They challenge us to think bigger, to question everything we know, and to confront the awe-inspiring vastness of the cosmos. So, which theory blew your mind the most? Was it the possibility of living in a simulation, the idea of a holographic universe, or the chilling implications of the Great Filter? Let us know in the comments below. And if you want more content that takes you beyond the stars and deep into the mysteries of existence, hit that subscribe button and turn on notifications. Thanks for watching, and remember, the universe is always crazier than you think.